everyone, welcome to Sangam Tutorials, Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science. So in the previous session we had solved some very important riders on right angle triangles. So in this session also we will be going with the same riders which are very important for examinations, which are taken from the previous year's examination question papers of Cbse and Karnataka state syllabus. So most important riders, you have to practice them. After practicing, you will get a good grip on the riders so that you will get the hold on it. You will get the roots of the riders. When any particular rider is given in your examination, you can easily analyze how to start and how to reach what is to be asked. So that is the beauty of riders. I hope you are enjoying the riders. More than some 12 to 14 riders have been already done in the previous sessions. So in today's session we will be going with some 4 riders which are very important, including the proof, that is an argumental proof for Converse of Pythagoras theorem is also included in this session, which is very important. You are going to enjoy it. It will be not asked in the examination, but still for your knowledge, for your excellence in geometry, I am presenting that. So let us enter into today's session. Very important. Here is the rider. In the figure, BL and CM are medians of triangle ABC. So you can see triangle ABC here. So BL is one of the median and CM is one of the median. So median in the sense it divides the line, that is where it is going to get terminated. That line is going to get divided into 2 equal parts. That's the median which divides the base into 2 equal parts. So here CM is the median. So therefore it starts from the vertex C and ends on the side AB. So therefore it divides the side AB into 2 equal parts. So here AM is equal to BM, and again BL is another median which is drawn to the base AC. So here BL median divides the base AC into 2 equal parts, that is AL is equal to CL, that is the median, that's the property of the median. So of triangle ABC, which is right angled at A, so it is not mentioned, so I will mention that angle A is right angle. So prove that 4 into BL square plus CM square is equal to 5 BC square. Very important, very beautiful rider. We are going to enjoy the proof for this. Okay, let us get into the data. So in triangle ABC, angle A is equal to 90 degrees. CM and BL are medians. CM and BL are medians. Okay, nice, right? So along with that we can also write AM is equal to BM. Okay, AM is equal to BM, and hence AL is equal to CL. AL is equal to CL. Okay, this is required for the proof what we give in certain steps. So to prove that, we are going to prove that 4 into BL square plus CM square is equal to 5 BC square. So that means 4 times the square on BL plus the square on CM is equal to 5 times the square on BC. That is very simple. 4 times the square on BL. So BL is this side, BL has a square on it. So the square on BL, the square on the side BL plus the square on the side CM, that is another median. So here when we add this area of the square on BL plus when we add the area of the square on CM and multiply that by 4, that reads as 4 times the square on BL plus 4 times the square on CM is equal to 5 times the square on BC. So this is BC hypotenuse. So the square on BC is it's very big because that is the biggest side of the triangle, because that is the hypotenuse. So the square on BC is 5 times the sum of the squares, that is BL square and CM square multiplied by 4, that is 4 times the square on BL plus 4 times the square on CM, that is 4 times the sum of the squares on the medians is equal to 5 times the square on the hypotenuse of the triangle. That is, we have to prove this. Okay? Right, let us enter into the proof. No need of any construction, data is sufficient for this. So let us take triangle ABL. You can see here, this is triangle ABL. So in triangle ABL, angle A is equal to 90 degrees, angle A is 90 degrees. So by applying Pythagoras theorem, we know that the square on the hypotenuse of the right angle triangle is equal to sum of the squares on the other two sides, that is the Pythagoras theorem. So BL square is equal to, therefore BL square is equal to AL square plus AB square is equal to AL square plus AB square. So this can be written as BL square is equal to, we will define this AL as AL is half of AC, because BL is the median drawn to the base of the triangle BC. So the median divides the base into two equal parts. So therefore AL is half of AC. So we can define this AL as half of AC whole square plus AB square. So this can be continued as BL square is equal to half of AC whole square is, the square applies for all three elements. So that becomes AC square by 4 plus AB square. So let us take this as equation 1. So now again we will select triangle AMC. We will select this triangle, that is triangle AMC. So in triangle AMC, again angle A is equal to 90 degrees, because in this triangle ABC we have three triangles. One is triangle ALB, another is ALM, another is ABC. So we have three triangles there. So in the second attempt I am going to take a triangle ACM or AMC. So in triangle AMC we can see angle A is 90 degrees. Therefore when we apply Pythagoras theorem, opposite to 90 degrees is CM square. So CM square is equal to AC square plus AM square. AC square plus AM square. So by applying Pythagoras theorem, so CM square is equal to AC square, we will keep it like this in the same manner. So here plus AM square, that is AM square. AM is half of AB. So therefore AM can be taken as half of AB whole square. So AM can be written as half of AB whole square. So this becomes CM square is equal to AC square plus, this square applies for 1, 2 and AB, for all the three elements we have to square it. So 1 square is 1, 1 into AB square is AB square by 2 square is 4. Take it as equation 2. So now we have two equations here, equation 1 and equation 2. Let us add both the equations. So add equations, or adding equations 1 and 2. Adding equations 1 and 2. BL square plus CM square, that is we are going to add the LHS. So BL square plus CM square is equal to, let us add their LHS parts. So AC square by 4, AC square by 4 plus AB square plus AC square plus AB square by 4. So it's very important. So now BL square plus CM square is equal to, below AB square we have 1 and below AC square in the denominator we have 1. So therefore take LCM for 4, 1, 1 and 4. So LCM becomes 4. AC square by 4 into 4 is AC square plus AB square by 1 into 4 is 4AB square plus AC square by 1 into 4 is 4 AC square plus AB square by 4 into 4 is AB square. So below this we have 1 as the denominator, go for cross multiplication. So 4 into this, 4 into BL square plus CM square is equal to this entire thing into 1. That is the same thing, AC square plus 4AB square plus 4AC square plus AB square. So 4 into BC square plus CM square is equal to 1 AC square plus 4 AC square is 5 AC square plus 4ab square plus 1ab square is 5ab square. So 4 into bc square plus cm square is equal to, when we take common as 5, because both the terms have 5 as a constant there, we can take out 5 as common. So remaining is ac square plus ab square. So here 4 into bc square plus cm square is equal to 5 into, right, let us wait for that result. Look at the figure. AC square plus AB square, let's see what it comes. AC square plus AB square. So in triangle ABC, what is AC square plus AB square? Here in triangle ABC, as angle A is 90 degrees, opposite to this is BC square, so therefore BC square will be equal to AC square plus AB square upon applying Pythagoras theorem. So AC square plus AB square, AC square plus AB square can be written as BC square, right? So we are at the end of the result. So 4 into BC square plus CM square is equal to 5 into BC square is 5 BC square. Hence it is proved. So it is a very important 3-mark rider on Pythagoras theorem. Very important. You have to practice this one, right? Okay, let us get into the second problem. Very important again. So it's based on converse of Pythagoras theorem. You have to guess here where you have to apply converse of Pythagoras theorem. So here, question itself tells you that through the triangle ABC is right angle triangle. So when you read the question itself, we should come to know that, or we can guess it easily that it's a problem based on converse of Pythagoras theorem, right? So in the given figure, in triangle ABC, AD perpendicular to BC. So let us take the diagram here. So it is triangle ABC and AD is perpendicular to BC, right? So, and AD square is equal to BD into CD. AD square is equal to BD into CD. So that we have seen in corollaries where we applied that is areas of similar triangles. That is the concept of similarity to the right angle triangle. I had given you 3 corollaries. Corollary 1, 2 and 3 I had proved it on the board. I hope in the previous session you can see that. So according to that the problem is based. So prove that triangle ABC is a right angle triangle. That is triangle ABC is right angle triangle. Let us see where the right angle comes and how the Pythagoras theorem is going to get applied. Let's see. Let us not decide angle B is 90, angle C is 90 or angle A is 90. Let's see. Then we will prove that. Okay. So according to data, so in triangle ABC, AD perpendicular to BC, right? And another thing given is AD square is equal to BD into CD. AD square is equal to BD into CD. So to prove that triangle ABC is a right angle. Triangle ABC is a right angle triangle. We have to prove this. So that's very important. It can be proved on the basis of converse of Pythagoras theorem. So let us enter into the proof. Very important. First we will select this triangle. So in triangle ADB, angle D is equal to 90 degrees. So in triangle ADB, angle D is equal to 90 degrees. So by applying Pythagoras theorem, please write the full format of that. So by applying Pythagoras theorem, opposite to 90 degrees is AB square. So therefore AB square is equal to AD square plus BD square. So AB square is equal to AD square plus BD square. So take it as equation 1. So select this triangle in triangle ADC. So in triangle ADC, angle D is equal to 90 degrees again, because angle D is 90 here. Opposite to that is AC. So AC square is equal to AD square plus BC square. So AC square is equal to AD square plus BC square. Take it as equation 2. That is by applying Pythagoras theorem. So add equations or adding equations 1 and 2. Let us add both the equations. So we'll add LHS with the LHS, so that becomes AB square plus AC square is equal to, we'll add the RHS, AD square plus BD square, AD square plus BC square. So AD square plus BD square plus AD square plus BC square, BC square, right. So we'll add these things. So AB square plus AC square is equal to 1 AD square plus 1 AD square is 2 AD square plus BD square plus BC square. So again AB square plus AC square is equal to, here it is given that AD square is equal to BD into CD. So instead of this AD square I can substitute BD into CD by taking 2 outside. So BD into CD plus BD square plus BC square. So AB square plus AC square is equal to, most of the students they come here and they will not be able to solve the problem to the further steps because they fail in observing a very important step here. So that's very simple. So here BD is raised to the power 2, DC is raised to the power 2, and we have BD into CD. This can be written as 2 into BD into CD plus BD square plus DC square. So this can be written like this. So this is in the form of A square plus B square plus 2 into A into B. That is A square plus B square plus 2AB. So A square plus B square plus 2AB can be written as, very simple, it is A plus B whole square. So it becomes AB square plus AC square plus is equal to BD plus CD, BD plus CD whole square. This is the format here. So AB square plus AC square is equal to, from the figure let us see what is BD plus CD. From the figure when you see what is BD plus CD, it is BC. So instead of BD plus CD I can write BC whole square. So when squared, this becomes BC square is equal to AB square plus AC square. So the square on BC in triangle ABC, the square on BC is equal to sum of the squares on the other two sides. So therefore, according to the converse of Pythagoras theorem, if a square on on one side of a triangle is equal to sum of the squares on the other two sides, then those two sides contain the right angle. So therefore, according to converse of Pythagoras theorem, that is, in a triangle, if the square on one side of a triangle or the square on the longest side of a triangle is equal to sum of the squares on the other two sides, then those two sides contain the right angle. So therefore, angle A will be 90 degrees. So according to converse of Pythagoras theorem, right, angle A is equal to 90 degrees. So if one angle of a triangle is equal to 90 degrees, then the triangle becomes a right angled triangle. So therefore, triangle ABC is a right angled triangle. Right? I hope you enjoyed the entire rider. Right? It's very important. It's a rider based on converse of Pythagoras theorem. Very important for 2 marks. Right? Okay, let us get into the third problem. Very important rider on converse of Pythagoras theorem. Purely a beautiful problem. You will really enjoy it. So listen to me very carefully. Look at the board. Right? If you have any doubts, please ask me through WhatsApp. Right? Okay. So in triangle ABC, CD perpendicular to AB, so 90 degrees on both sides. CA is equal to 2AD, that is, length of AC is twice the length of AD. And again, BD is 3AD. This BD is 3AD. So that means the length of BD is 3 times AD. Length of BD is 3 times AD and length of AC is 2 times AD, right? So if this is the thing, prove that angle BCA is equal to 90 degrees. BCA is equal to 90 degrees. It's a beautiful problem. Let us get into the data, right? So in triangle ABC, CD perpendicular to AB, CA is equal to 2AD and BD is equal to 3AD. So to prove that, we have to prove that angle BCA is equal to 90 degrees. So no need for any construction, data is sufficient here, right? So let us get into the proof. Very important. Okay, now as CA is twice AD and BD is thrice AD, so therefore we will guess AD. So let AD is equal to x units. So if AD is equal to x units, as AC is twice AD, then AC becomes 2x units. And as BD is thrice AD, therefore BD becomes 3x units. It's very simple. Once again, AC is twice AD. So I have guessed AD as x units. So as AC is 2 units, that is 2 AD, then it becomes 2x. And BD is 3 AD. So BD is thrice AD. So therefore as AD is x, then BD will be 3x. So we will do it formally. So let AD is equal to x units. So therefore AC is equal to 2x and BD will be equal to 3x units. It's understood, it's units. We do not know whether it is in centimeters or meters. Just let us mention generally as units. Okay. So now in triangle ADC, angle D is equal to 90 degrees. So by applying Pythagoras theorem, so you have to write the full format of that in your classwork. So AC square is equal to CD square plus AD square. CD square plus AD square. Okay. So AC square is 2x whole square. 2x whole square is equal to CD, we do not know that, so we will carry the same thing, plus AD is x, so that becomes x whole square. So make CD square as the subject. So 2x whole square is 4x square is equal to CD square plus x whole square is x square. So therefore CD square is equal to, transpose this x square to LHS, that becomes 4x square minus x square. So CD square is equal to 3x square. So let us take square root on both sides and we will take CD. We will find out CD here. So therefore square root of CD square is equal to square root of 3x square. Square and root cancels. So CD is equal to, as 3 is not a perfect square, the root symbol for 3 remains, but x square is a perfect square. So therefore square root of x square is square and root cancels, x comes out, that becomes x root 3. So the length of CD is x root 3 units. Now this is x root 3, right? Okay, this is x root 3. So now we will take triangle CDB, right? In triangle CDB, angle D is equal to 90 degrees, right? So by applying Pythagoras theorem, we will apply this. Opposite to 90 degrees is BC square. So BC square is equal to CD square plus DB square. CD square plus DB square. So BC square, we do not know the value of that. So BC square is equal to CD square is, CD is x root 3, that is x root 3 whole square plus DB square is 3x whole square. 3x whole square. So BC square is equal to x root 3 whole square is x square into root 3 whole square, it becomes root 3 whole square because square applies for both the terms. So x square is x square, root 3 whole square plus 3x whole square is 9x square. So BC square is equal to x square into root 3 whole square is square and root cancels, x square into 3 is 3x square plus 9x square. So that is that becomes 12x square. So let us take square root on both sides. Square root of BC square is equal to square root of 12x square. So square and root cancels. So BC is equal to, this 12 can be written as 4 into 3 into x square. 4 into 3 is 12. So among 4, 3 and x square, 4 and x square are perfect squares. So when they are taken out, so BC is equal to, it becomes 2x root 3. The value of BC is 2x root 3. So now, the value of BC we have got, that is 2x root 3. So one thing we will do, we will take AC plus, we'll add this AC square plus AB square. Let us see what happens here. So here AD plus BD, AD plus BD is x plus 3x. So AB can be written as, AD plus BD, AD plus BD. So AB is equal to x plus 3x, x plus 3x, which is equal to 4x. So when we do squaring on both sides, so that becomes AB square is equal to 16x square. Keep it inside a box. AB square is 16x square. Now we will take the squaring on AC and BC. So therefore AC square plus BC square is equal to, AC is 2x whole square, that is 2x whole square, plus BC is 2x root 3 whole square, 2x root 3 whole square. So AC square plus BC square is equal to, 2x whole square is 4x square plus 2x root 3 whole square is 4x square into 3, that is 2x whole square is 4x square, root 3 square cancels and 3 remains. So 4x square plus BC square, AC square plus BC square is equal to 4x square plus 4x square into 3 is, that is 12x square. So AC square plus BC square is equal to 16x square. So you can put it inside a box. And when you compare these two, AB square is equal to 16x square and AC square plus BC square is also equal to 16x square, then AB square, therefore AB square is equal to AC square plus BC square. So let's see and check this in the diagram. So here AB square is equal to, that is square on AB is equal to the square on AC plus square on BC, that is AB square is equal to AC square plus BC square. So then AB becomes the hypotenuse, then these two sides become the remaining sides. Those two sides become the remaining sides. Then those two sides should contain the right angle, that is AC and BC side should contain the right angle. So in triangle, this happens in triangle ABC. So therefore angle C is equal to 90 degrees. That is the thing we have to prove. So therefore angle BCA is equal to 90 degrees. So this is the answer, and this is according to converse of Pythagoras theorem. So this is very important rider on converse of Pythagoras theorem. Very important. You have to practice this well, right? Okay, let us get into the fourth rider. I don't want to call this as a rider because it is the proof for the converse of Pythagoras theorem. So it's not a rider here. So it's a very important proof, right? Where it's not asked in the examinations. Previously in Karnataka state syllabus, maybe in the year maybe 2013 or 14 or something. So the particular proof was asked in the examination. So after that I have not seen in any of the exams being asked. So but this is very important for your knowledge and for your enjoyment in geometry. I am presenting the proof for converse of Pythagoras theorem, right? So if the square on longest side of a triangle, so you have to imagine a triangle here. So in this triangle, the square on the longest side of a triangle. That is, we do not know what type of triangle is that. We should not consider that as, sir, it is already a right angle triangle. No, it's not a right angle triangle. Just it is a some type of triangle, that's all. So in that triangle we have the longest side. When compared to the other two sides, one of the side is the longest side, and we have built a square on that. So if the square on the longest side of a triangle is equal to sum of the squares on other two sides, then those two sides contain a right angle. So you are well aware of the statement. So we will get into the hypothesis part. If the square on the longest side of a triangle is equal to sum of the squares on other two sides. So we have a comma here. So until here it is the hypothesis part of the statement. So by reading the hypothesis part of the statement, we have to imagine or we have to create the diagram. We have to name the diagram, and the description of that diagram what we have created, we have to show that in data. So we'll do that first. So if the square on longest side of a triangle, so diagram, let us get into the diagram here. So this is a triangle, take it as triangle ABC, so it's not right angle. If the square on the longest side of a triangle, so I am going to consider AC as the longest side of the triangle here, is equal to sum of the squares on other two sides. That is, the square on AC is already equal to the square on AB plus square on BC. It has happened. So other two sides, then those two sides contain the right angle. So if this becomes the longest side, then these two sides become the other two sides, and these two sides contain the right angle. We have to prove that. Okay. So let us write the data. Description of the diagram is data. So in triangle ABC, AC is greater than AB and AC is greater than BC. So one point I am going to, or instead of these two things you can write AC is the longest side, right? So AC square is equal to AB square plus BC square. That is, the square on the longest side of the triangle is equal to the sum of the squares on the other two sides. So that is given. So let us get into to prove that. So we have to prove that angle ABC is equal to 90 degrees. So in order to prove this triangle, this angle ABC is equal to 90 degrees, using this data it's not sufficient. So therefore we have to go for a little bit of construction, a small construction we are going to do, right? So draw a perpendicular at A, draw a perpendicular from A, perpendicular to AB, draw a perpendicular at A, or draw a perpendicular at A which is perpendicular to AB such that the point, we can name it as D here, such that AD is equal to BC. AD is equal to BC, and join this BD. Join this BD. So once again, so draw a perpendicular to AB at A such that AD is equal to BC, and join BD. Right. So this is the construction part. It's very important. Right. So let us enter into the proof. It's very, very important. Very, very important. Now we will take this triangle. In triangle ABD. In this triangle, ABD. So in triangle ABD, angle A is equal to 90 degrees. Yes, angle A is equal to 90 degrees. According to the construction, we have got that. So here clearly for this triangle ABD we can apply Pythagoras theorem. So BD square is equal to AD square plus AB square. So BD square is equal to AD square plus AB square. Right. So this is according to the construction we have got this, right? But we can do like this. So BD square is equal to instead of this AD I am going to write BC, because AD is equal to BC. So instead of AD square, I am going to write BC square. BC square plus AB square, right? But according to the data we have, AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. So here, when you compare these two, BD square is equal to BC square plus AB square, and AC square is also equal to BC square plus AB square. So therefore, BD square is equal to AC square. You can take it as equation 1 and equation 2. So from equations 1 and 2, BD square is equal to AC square. So therefore, BD is equal to AC. This is a very important result. If two squares are equal, if the areas of two squares are equal, that is this thing. If the areas of two squares are equal, then the sides of both the squares will also be equal, that is BD is equal to AC. So now we will select both the triangles. We will select these two triangles here, in triangle BAD and triangle ABC. In triangle BAD and triangle, right, ABC. ABC, right. So now AD is equal to BC, AD is equal to BC. So this is according to the construction we have got this. So that is AD is equal to BC, and just now we have proved that BD is equal to AC. Just now we have proved that BD is equal to AC, that is this BD is equal to AC. Just now we have proved here, and for both the triangles AB is common. So AB is common. AB is common. So therefore, for in this triangle and in this triangle, three pairs of corresponding sides have become equal. So in the sense, this side is equal to this is equal to this, and in these two triangles, this side is common. So therefore, both the triangles should be congruent according to SSS congruency. So if three sides of one triangle are correspondingly equal to the three sides of the other triangle, then both the triangles should be congruent to each other. Okay, so therefore triangle BAD is congruent to triangle ABC according to SSS congruency or SSS postulate. Right. So if these two triangles are become congruent, then the 6 elements of the first triangle are correspondingly equal to the 6 elements of the second triangle. So among them, I am going to take angle BAD. This angle should be equal to angle ABC. This angle, right? So angle BAD is equal to angle ABC. Is equal to angle ABC. So here I can call it as CPCT, corresponding parts of congruent triangles. So, but angle BAD is equal to 90 degrees. But angle BAD is equal to 90 degrees. Angle BAD is 90, but angle BAD is equal to angle ABC. So therefore, angle ABC should also be equal to 90 degrees. So that is what is that? It has to be proved. So therefore, if the square on the longest side of a triangle is equal to the sum of the squares on the other two sides, then those two sides contain the right angle. So we have proved this logically. So here in triangle ABC, AC is the longest side. The square on the longest side of the triangle is equal to sum of the squares on the other two sides. Then those two sides, that is this side and this side, should contain the right angle. That is angle ABC is equal to 90 degrees. We have proved that, right? So this is by argument, that is the logical process of proving any enunciation or a proposition. So this is very important for your knowledge. I hope you enjoyed it. So in tomorrow's session will be the last session for the problems on Pythagoras theorem. So in tomorrow's session I will be going with application questions. So as we are at the end of the chapter, so tomorrow I am going to conclude the chapter and we will be starting with chemistry and trigonometry in the coming session. So I'm very happy at this moment. I'm very happy to announce that we are starting online classes for 9th standard mathematics and science for state syllabus students and also Cbse students, which is going to start from 24th of this month from 8 AM onwards on the same YouTube channel Cbse online classes. So please inform all your juniors to watch the videos and gain knowledge at this time of COVID-19. So don't waste your time, keep learning, learn something new each and every day so that your days and time should not go wasted. So with this, stay home, stay safe and keep learning. Thank you.